One, if not the biggest, of preoccupations by the maintenance manager and his staff is the never-ending quest for continuous improvement. Indeed, the maintenance technology industry dangles that hook, and we take the bait again and again. Authors and consultants lead the charge with an alphabet of solutions: PM, CBM, RCM, EAM, TPM, standards ISO 14224, 55,000, and the list goes on. But as the years and decades pass, do we ever take stock of the benefits? I mean, from a hard-nosed financial management accounting perspective. Do we calculate the actual return on investment from these initiatives? Or is their value simply asserted as a matter of common sense? Are we placing too much faith in our maintenance thought leaders? Well, today I want to delve into the largely unexplored territory of investigation of evidence for reliability and profitability improvement. I'll assume that you've already viewed the YouTube video series, Achieving Reliability from Data. If you haven't, why not do it now? I'll still be here waiting for you when you get back. In part 2 of that series, we performed a unique set of procedures with which to continuously improve our RCM knowledge. We learned how to use a specialized dashboard to track and spur on that improvement. In this video, we'll track, improve, and measure the financial performance of our CBM policy. Start the exact CBM modeling program. Open the CAT 340-ton working model database. We'll select the model we previously built. Hit Modeling. Select Current Model. Select the iron-lead model we developed in the modeling exercise. It was called IL. Now hit the modeling button on the flow diagram. Hit Decision Model. Hit the Cost Comparison button. The first dialog that pops up asks us if we need to exclude certain histories in the sample prior to conducting our performance evaluation. This step is designed to remove as much uncertainty as we can before proceeding with the calculation. The histories, or life cycles, are points in the sample we are about to analyze. In order to be sure that our sample reflects the true failure behavior of the item, or failure mode, we want to remove histories that have only just begun at the time of sample, or histories that are missing a substantial number of CBM inspections, or histories that are partially inside an adjacent time window whose performance we want to compare with. It's easy to locate histories that we might want to exclude. Just use the appropriate tool in the software. Close the Exclude History dialog box for a moment and hit View Histories. Here we see a timeline for each unit in our sample. Every event in each history is labeled. The green circles mark the beginning of a lifetime. The blue circles indicate CBM inspections. The red triangles designate the failures, while the large yellow triangles symbolize suspensions. The small downward-pointing yellow triangles are non-rejuvenating events that we discussed in Part 1. A quick examination of these timelines assures us that there are no histories that we need to exclude. All histories have at least 3 or 4 CBM inspections prior to their ending. The first history of each unit begins inside the sample, and for purposes of this video, we'll examine only a single calendar window. The way to compare performance between 2 different sample windows will be obvious to you at the end of this demonstration. Now let's go back to the Exclude Histories dialog and tell the software that the entire sample should be included in this analysis by hitting OK. The next dialog box that pops up, called Edit Selected Histories, allows us to refine individual data records. We retained all histories in our sample. That fact is indicated by a -1 in the first column of every record. Each row represents an individual event. Say that a particular event is suspicious, for example, an obvious spurious reading of iron that became reasonable on the next CBM inspection. We'll direct the software to exclude that particular record by changing the -1 to 0. With those simple refinements out of the way, we're ready to conduct the CBM performance comparative analysis. To proceed, simply hit Apply and OK. The calculations have been executed and the results appear in this report. Let's interpret the report. We'll begin with the first table called Summary of Decision Model Parameters. This table reviews the business data used in the decision policy. In another video, I show how to perform a sensitivity analysis to determine whether more precision in the business factors is required. Usually, the sensitivity analysis finds that management's estimate of the ratio of proactive and reactive costs are accurate enough for building and assessing the optimal decision policy. The next table is titled Summary of Events and Decided Histories. There are 3 rows whose headers are Current, Exact Applied, and Fitted Exact Applied. The row whose heading is Current tells us what actually occurred in our sample. Of the 13 actual histories, 6 failed, 3 were preventively renewed, that is, suspended, and 4 are undecided. That is, at this time, we don't know whether they will eventually fail or will be preventively renewed. At the present moment, they are still operating. The next row header is Exact Applied. This row tells us what would have transpired had we applied our optimal model to the sample. Only 1 history would have ended in failure, 6 would have been preventively replaced, and 6 would currently be operating. We conclude that reliability would have been significantly improved. But at what cost? Would our policy have been so conservative that it would have been unprofitable? We will resolve this question in our examination of the next 2 tables. But before we do, let's check the last row in this table called Fitted Exact Applied. This row displays the results of adjusting our model to the sample so as to maximize profitability. In other words, it tells us what would have happened had we built the model based on that sample. Now we will examine tables A and B. The difference between these 2 tables is the following assumption. In table A, the undecided histories were assumed to have been preventively replaced at the end of the sample window. If we expect that the undecided histories will behave similarly to the other histories, this assumption will not distort the final answers. Furthermore, if the number of undecided histories is not very large, performance is appropriately estimated. Table B results exclude the undecided histories from consideration because one may argue that we don't know how these histories will impact profitability. Table B may be considered more conservative than Table A. One may consider the assumptions of A and B as defining the extremities of the envelope of possibilities of the model's economic performance. If both provide satisfactory results, we may confidently estimate the bottom line shareholder value of the current, past, and proposed future CBM policies. So what can we conclude from these tables? We can base our conclusion on the row labeled Exact. This row projects the performance of our model going forward. So in this case, our expected improvement in bottom line profitability will range between 7 and 24%. But more importantly, we have a method that will bear the scrutiny of the most exacting financial officer whom we need to convince that a given CBM policy carries a defensible return on investment. To conclude, this analysis procedure provides a credible way to judge the potential benefits of a proposed CBM policy. It also provides a way to track and compare CBM performance in different calendar periods, and thereby document improvements in maintenance profitability. Thank you.